one of the main tools which is useful with Agile MDE is to generate code generators. So code generators can be quite expensive and time-consuming to write manually. So the idea of this code generation by example is to generate a code generator from source and target pairs, source and target example pairs of the source and target languages. Now, normally the source language is OCL and UML, and the target language is some programming language. So this process here is for code generation of C, and the example files in this case are some paired UML and C code. So on the left hand side you can see the UML version. This is separated by tabs from the C version of the same thing. So we have examples, usually 2 examples for each kind of statement. But for more complex statements like for loops, we may need to have more examples. There's actually four examples of for loops here, because it's a complicated mechanism. 3 examples of while loops, and so on and so on. So what you need as the input for code generation by example are these example files, and there's normally 4 example files, which are ones for types, expressions, statements, and declarations. This is an example for statements, obviously. Now, the actual process of creating the code generator involves a search, and it's a search over tree-to-tree functions, because these examples are not represented as text, they're represented as parse trees using parsers for the relevant languages. For the source language, we already have a parser for OCL and UML. For the target language, we normally use an antler parser. So in this case, we've used an antler parser for C, for the C language, ANSI C language, which has been used to parse these target examples into parse trees. So this can take some minutes, the searching for tree-to-tree functions, and the time is large for more complex target languages. In the case of C, the problem is that the C grammar is quite deeply nested. So this is actually what's being learnt here, is we're learning tree-to-tree functions. So a tree function from, say, the tree representing binary addition expressions. In OCL, that's a simple parse tree with depth 1, essentially. But in C, the same thing has a much greater depth because of the complexity of the grammar, the various variations of expressions, and so on. So the learning process has to unwrap these trees. It has to discover the structural correspondence between the source tree and the target tree, and of course that takes some minutes, but I think it's still a lot faster than, say, a neural net-based machine learning, which can take days to do the same kind of learning. And the advantage here is that the rule that's learned is completely precise. So this applies to any binary expression of this format, is going to be translated into a binary expression in C. The other thing that's worth pointing out here is that the target is going to be correct C syntax, because it's going to be parsed into a parse tree that's a valid parse tree. Okay, so that's what's being learnt behind the scenes. What we end up with is a CSTL code generator. Now, CSTL is this simple string substitution language which we use to write code generators. Here's an example code generator for the Go language, and essentially each kind of expression, like a unary expression, is mapped depending on its operator into a corresponding operator in Go. And we have things for binary expressions in the same way. So this code generator is the ultimate output of this learning process, but as I say, behind the scenes what you're learning is actually parse tree to parse tree mappings, and this is simply the text representation of those parse tree to parse tree mappings. Now, along with the examples, what you need as input is a configuration file. The configuration file tells the training CGBE training script what parser to use for the target. In this case, it's the Yantler C parser, and also tells it which grammar rules of that parser to use to parse which kind of things. So we essentially have 7 kinds of thing in our examples: types, expressions, statements, features of classes, classes themselves, local variables within statement blocks, and enumeration definitions. Some of these may be missing for different languages. For C, types are parsed using the type specifier rule, expressions by expression, statement by statement, and so on and so on. Local variables, they're really a kind of statement. They're parsed as a block item. So you need to have this little configuration file. That's the only input that's needed to this script, CGBE train. And yeah, the end result is a rule set in CSTL, which you can then use as a code generator.